Alright everybody, how you doing for this semester in my Embedded 2 course? I decided to build a drone and using a Kk2 board. I'm going to be controlling the Kk2 board command through drones with the Raspberry Pi and the Arduino. So I'm going to test it right now by SSHing it, and from there I'm just going to go over the code. So you know how I did it. The code will be actually attached to the video, so you guys can use it. So if everybody knows, the Kk2 board has to be armed. So we did that, so it's automatically, when I connect the battery, it's gonna run. It's gonna be armed. So let me go through that. So see, red light is on. Says armed, so we're good to go. So currently I have my Python for the Raspberry Pi. I have my code and everything that I'm going to go over, so I'm just going to test it. And here he goes. So you hear 2 beeps, that means it hears it, and it's going through a for loop because I don't want it to like go from the speed to increase really fast. So it's gonna slowly go. There it goes. And so it gets to a certain speed, it'll stop. So I don't want it to, like, I'm indoors. And there it goes. Now I can stop it. Let me turn it off. So not waste any battery. So that's my project. Eventually it's gonna fly by itself. So going through the Python code, not Python, I'm going to go through the Arduino code. So I'm using 2 libraries, string and servo, because they're already given, so it makes it a little bit easier. We define the min packet size to be 2. It's pretty standard for a binary protocol when working with packets. You got servo. All these servos are named throttle, elevator, aileron, elevation, rudder. This is going to be for the future. I'm going to have it fly forward, backwards, up, down, all by itself. So let me open this real quick. So let's go nano. So I'll work on nano, not Vim. So let's go. All right, so let's just open that. So this is the code. So I'm gonna actually, yeah, so let's keep over here. So the header is set motor. So they actually have to be on Python on the Raspberry Pi, and our Arduino code have to be the same, so they can, what you're, calling and whatnot. So you just use enums for this. This is the baud rate. These are the pins that we're using in Arduino. So it's everyone's PWM, and like I showed before, has to arm itself, has a safe mode. So this right here will allow it to arm automatically. Okay, so it's just like when you're using the joystick, you have to bring the left stick, the throttle stick, left while it's at 0. So you have to go all the way to the right, and hold it for 2 seconds, and it arms itself. So by doing this, actually does it automatically. This is the binary protocol, pretty much. It's very common. This is like pretty much what everybody uses. So it's you checking if the serial is available, and it's waiting to hear which header command we're looking for. So if you see we're looking header command, if we say 0, we're looking for the set motor. So we're looking for that, and then we're going to. This is for the payloads. Pretty much just when we talk about payloads, we're talking about the length of the payload. So it's, I'll show you down here. We're using 2. So, and then we're gonna call the function handle packet, and that's it. So let's go to handle packet. So this is our function. We're doing a switch case. pretty simple to use. So we header command set motor. So we're calling the set motor command, and if it's a length of 2. So if you, I'll show you in a minute. That's how we define the length of 2 in Python. So because we're calling two bytes, so it's we're doing 8 bits, then shifting it, because we're using, if you notice up here, it was 1187 PWM, so that's it has to be in 2 bytes. So and that's what we have at 16 bits right here, 2 bytes for the payload. So it's going to do payload 0, the first one. It's going to shift it 8 and end it with the first one, which is going to be 1s. So serial that right value, making sure that something's actually coming through. It's pretty much a check. And if the value is 1, because it actually becomes 1s and 0s, it's going to go through this loop. So it's going to go from speed equals 0. Doesn't have to be a float. I was doing something else with that. So so speed is less than or equal to 70. It's going to increment by 5. And then I'm going to keep doing that for each motor. Okay, so you want it to kind of like each motor kind of like go at the same speed, because if not, it will just tip over. So we have a delay here. So it's going to for every second up to 70. It's going to do that. It's going to go 5, delay, 10, delay, and all that stuff. So, and then because I don't want it to keep going through the loop. I want it to actually stop at the certain speed, because I want it to actually get it to hover. So if the speed equals 70, which is the final right here, the new speed, the integer new speed is going to be 75, and that's going to be the new values for the motors. So, and that will also, to make sure that it's actually going through this, I put serial.write fly, saying, hey, it's going to fly. If it's 0, you can actually do, decrease the speed. If it's hovering, you can have just, by decreasing the speed, it'll just slowly come down and land. But since I'm indoors, I actually just have everything at 0. So it's just going to be motors off. Okay, so on the Python side, so we're using, let me just focus there. All right, so we're using enums, serial time. Don't worry about the RPI GPIO. That was for something else I was doing. If you notice, class is just pretty much the same as the def enums. So it's the same thing. For this is just Python. Set motor 0, min packet size 2, and this is the packet. So if you never worked with a packet, it's pretty generic. So you don't have to really change too much. You just gotta understand it. So we're header command set motor. So we're calling this the packet set motor, which has a length of 2. Okay, so we're gonna call the 0. Okay, which is set motor for length of 2, which is these two. So it's gonna send the value. It's gonna shift everything to the right 8 bits, and then that new value is gonna be ended with 1 1 or FF, if you want to say, to make sure that and then it's gonna serial.write the packet. The hardware serial.serial./dev.t, that's allowing us to actually communicate through a USB. So you need that there. So it's it can be a different USB name. The best way to do that is to do when you get to the terminal command line, you can do a CD//, and that'll send you all the way back to where you need to do. Then you do a cd.dev, and then you do a ls, and it will actually list a bunch of ports, if you may, and by connecting and disconnecting it, the Arduino through USB, you can actually notice that this will disappear. This this port. So this kind of shows you that this is the one that you're actually working with. So I decided to put a print hardware.name, which will print this part right here, which will tell me that it's actually sending through a USB. It's just another check. You don't want to, it's a good way to troubleshoot stuff. Time that sleep too. You need to have that there. If you don't, it won't communicate properly. You need to give the Raspberry Pi and the Arduino about 2 seconds to simply kind of like adjust and so to start communicating. And then you're gonna print set motor. The print is just pretty much just saying just want to make sure that something's actually happening. It's a good way to troubleshoot. Like I said, it just checks that everything's working. We're gonna do a set motor, so we're gonna we're gonna call this function. We're gonna send it through a USB, and we're gonna send it at a value 1187. So that's when the 2, which is 2 bytes, comes in play. That's what we're using 2 bytes for. So if you have any questions, pretty much you can just message me, and I am always willing to help. I'm going to be adding these codes onto the video, and yeah, hope you like it. And if you want to just do it with Arduino, it's just, you can control this with Arduino. It's at the only part you really need. Sorry, I kind of want like a tangent right there. All you pretty much need to do is to disarm right there, this little section right here. That will disarm the Kk2 board, and the rest you can just pretty much do yourself as long as you know how to do some Arduino coding. So thank you for watching, and have a great day.